Hello students, welcome to the Unit 2 Note Section 5.5. At this time you can pause and begin the warm-up, and I will begin in just a short second. Okay, so the warm-up says, graph the triangles with the given vertices, list the sides in order from shortest to longest. And so what I'm going to do is I'm going to graph this. It looks like I'm going to have to count by no, I'll graph it 5, 0. So 2, 4, 5, 0. This is A. B is 0, 8. So 2, 4, 6, 7, 8 is right about there. And C is 0, 0. So here's C. That's A and B. You know what, I'll just erase that and I'll just label it as C. Okay, so here we have something that has a length of 8. We have something that has a length of 2, 4, 5. And this right here has a length of, we're going to say length is greater than 5 and 8. Just because it's definitely longer. Look at how much longer that is on the diagonal there. So what I'm going to do is I'm going to put these in order, the sides in order from shortest to longest. So the shortest side is AC. The middle side is CB, or let me go alphabetically in order. BC, and then AB is actually the longest side here. Okay, the next one, we have 1, 4. So 1, 4. We have -5, 0. And we have 1, 0. So that's we have P, Q, and R. So I'm going to connect these. That looks like it has a length of 4. This looks like it has a length of 2, 4, 6. And then PQ, I don't know the length because it's diagonal, so I can't just count boxes. But I'm going to say that the length is greater than 4 and 6. So it looks like PR is the smallest, is the shortest side. And then QR is the middle. And the longest is PQ. All right, this last one, 2, 0, 4, 5, and 5, 0. This was excuse me, this was intentional. Let's see, 4, 4, 5. This was intentional. That's Z. 4, 5 is Y, and 2, 0 is X. So this definitely has a length of 3. And each one of these, it's kind of hard to tell, but here's what's happening. This is 3. The middle would make each of these sides. So if it was right here in the middle, it would make this side equivalent to this side. However, because it shifted over just a little bit to the right, that makes the longer side the one on the left. Think about the further out I put this. Look how much longer the left-hand side of my triangle gets from the right side of my triangle. So what I do know, I don't know the lengths right now, but what I do know is that this is longer than it's longer, so it's the length of this is definitely greater than 3, and the length of this is greater than both. Is greater than all of that I starred in blue and that I labeled in blue. So xz is the shortest, yz is longer, and the longest is xy. Okay, so it was a warm-up. Why do we do a warm-up like that? It's a little bit different than what we were doing with the beginning of our logic. It's because we are starting another logical set of statements, but this is involving the inequalities of things. So what does it mean to be an inequality? Well, that means it's either lesser or greater than something. We also have unique ones that are lesser than or equal to, or greater than or equal to. But for inequalities in a triangle, let's think about this. When you empty a container of juice into two glasses, so here's your original glass, you dump it into these two. It's difficult to be sure that the glasses get the same or equal amounts, right? It's kind of tough. I mean, maybe one has a little bit more than the other, but whatever. But here's what you can be sure of. You can be sure that each glass holds less than the original amount in the container that you initially poured it out of. So if this had 10 ounces and you put 5 and 5, these each still have less than 10. Or what if you poured 4 and 6? Well, it's still less than the 10 that was in the initial. So this is a simple application of the comparison property of inequality. So the comparison property of inequality states that if A equals B plus C, if A equals B plus C and C is greater than 0, then A is greater than B. Okay, so any amount that takes up C, so that 1 ounce, that means that B has to be 9. So A will always be the 10 ounces. So A is your 10 ounces. 10 ounces is equal to 9 and 1. So if C is 1, then B is 9, which means that 10 is always greater than 9. So when you're taking that C amount away, B will always be lesser than A. And in a triangle, 1 is greater than 2 and 1 is greater than 3 because 1 on the exterior is the sum of 2 and 3. Therefore, it is definitely greater than 2 and greater than 3 individually. So that's your corollary to the triangle exterior angle theorem. Okay. All right, so let's apply that. Oh, we have a little bit more. So in this case, if xz is greater than xy, then my angles also must be greater in retrospect. So let's think about this. Your smaller angle is if this is smaller, if this angle is smaller, that means, let's see. Let me do, I don't know how I want to label this. Let me label this in order. So this appears to be the smallest angle. This appears to be the middle angle, and this appears to be the largest angle. Well, guess what you can say about the sides? Your biggest side is going to be opposite your biggest angle. Your smallest side is going to be opposite your smallest angle. And your medium side is going to be opposite your medium angle. So just like your sides go in order from smallest to greatest, your angles go in order from smallest to greatest, and they are opposite the sides. And vice versa. So this one said if the sides are greater, then the angles are greater. Yep. And the same thing's going to happen for this one. So if the angles are greater, then the sides are going to be greater. So actually, I should have drawn this a little bit backwards. I'm sorry, I did the wrong. You know what? I just wrote these backwards. So I'm going to erase that arrow, and erase that arrow, because what I'm going to say is that if the sides are greater, then the angles are greater, and if the sides are lesser, then the angles are lesser. This is the reverse of that. this is smallest angle is going to be here, middle angle is here, largest angle is here, and that is going to be the sides that they connect to, not connect to, but that they are in a relationship with for lengths. So if angle 1 is the smallest, if angle 1 is smaller, then that will be your smaller side. If angle 2 is in the middle, that's 2, and then 3 and 3. So smaller sides are across from smaller angles, and smaller angles are across from smaller sides, and vice versa. And then the sum of any two sides of a triangle, are greater than the longest side. Okay, then the third side. So if I have sides 3, 4, and 5, what I know is that, let's see, xy, so 3 and yz is, I got this backwards, sorry, 3, 4, and 5. So 3 plus 4 is greater than 5. 4 plus 5 is greater than 3. And 5 plus 3 is greater than 4. So two sides will always be greater than the third side when summed together, no matter what in a triangle. Okay, that was a lot of information. We're going to do examples with all of these. So here's a first example. Let's test it out and make sure that this can be a triangle, right? So I'm going to do 3. Here's 3, 3, and 5. So 3 plus 3 is greater than 5. That's true. 6 is greater than 5. Good. Then 3 plus 5 is greater than 3, which is good. And then again, 3 plus 5, because I'm going to do my other two sides, is greater than, 3 plus 5 is greater than 3, and 3 plus 5 is greater than 3. So this works. Well, let's check out this one. This one doesn't work. 2 plus 6 is greater than 2. Good. 2 plus 6 is greater than 2. That's good. 2 plus 2 is greater than 6. That is false. That's the reason why we can't have a triangle, given those side lengths. All right, let's take a look here. Example 1, applying the corollary. So in the diagram, measure of angle 2 is equal to the measure of angle 1. So what that means is that if measure of angle 2 is greater than anything, then it will also, we can say the same thing about 1, that 1 is also greater than that thing, or vice versa. So by the isosceles triangle theorem, explain why the measure of angle 2 is greater than the measure of angle 3. Well, so if the measure of angle 2 is greater than the measure of angle 3 is what we want to prove, then what we could say is that would also mean that the measure of angle 1 would have to be greater than the measure of angle 3. Because if 1 and 2 are equal, then and 2 is greater than 3 is what we're trying to prove, then in this case, 1 also has to be greater than 3. So why would 1 be greater than 3? Well, if I look at this as a triangle right here, if I look at just this triangle here, this might take you a while to catch on. It takes practice, but take a look at what's happening right off of, oh, that didn't really work that well. Let me try this again. Yeah, there we go. That's closer to being the triangle. So take a look at what's hanging off over here. This is a exterior angle. So angle 1, the measure of angle 1 is equal to the measure of angle 3 and the measure of angle 4, because these are the two remote remote interior angles, and they are in connection with, they are the sum of them is equal to the measure of angle 1. That means that the measure of angle 1 has to be greater than the measure of angle 3, and the measure of angle 1 also has to be greater than the measure of angle 4. So if the measure of angle 1 is greater than the measure of angle 3, which is proven, then in that case the measure of angle 2, because it's equivalent to the measure of angle 1, so that concludes that the measure of angle 2 has to, the measure of angle 2 has to be greater than the measure of angle 3. So it's all about equality, and if something is greater or lesser, then the thing it's equal to is also greater than or lesser than it. And that's kind of like a really, so it's kind of a tough proof, I get it. But again, if 1 is equal to 2 and 3, that means 1 is both greater than 3 and greater than 4, and it's only equal to them when they are combined, when they are added together. So if 1 is greater than 3 and 4, and 1 is equal to 2, then by the transitive property here, 2 is also greater than 3 and 4, which is what we had to explain. Okay, explain why the measure of OTY, so OTY, is greater than the measure of angle 3. Well, if the measure of angle 2 is greater than the measure of angle 3, and if the measure of angle 2 is also measure of angle 2 is greater than the measure of angle 4, then oh wait, sorry, we don't need that. If the measure of angle 2 is already greater than the measure of angle 3, and then we add, so we are adding to it, if the measure of angle 2 is greater than the measure of angle 3, and we add the measure of angle 4 to the measure of angle 2, then it is definitely, then it is still larger or still greater than the measure of angle 3. So just adding something to it keeps it as large, keeps it larger than what it is. So let me move this around because this is kind of messy. So that is there. That concludes. So we'll say, so that is true. Oh, wait. That's something different. So the measure of angle 1 equals the measure of angle 3 and 4. So measure of angle 1 is greater than the measure of angle 3. The measure of angle 1 is greater than the measure of angle 4. So the measure of angle 2, what did I say? Measure of angle 1 is greater than the measure of angle 4. That means that the measure of angle 2 is greater than the measure of angle 4. Oh, no, the measure of angle 2 is greater than the measure of angle 3. Yep. All right. Sorry. Just a lot to say and do. All right. This next one, A landscape architect is designing a triangular deck. She wants to place bushes in the two largest corners. Which corners have the larger angles? So it looks like this side is a length of 27 feet. This is a length of 18 feet. And this one is a length of 21 feet. So 27 feet is the longest side, meaning that the largest angle is opposite the greatest angle is opposite the longest side. So in this case, that one, angle B, is the largest. Let me see. I need to find a color that will work well. Angle B is the largest. Is not working well here. That works. The largest. And then in this case, we also have the middle. This one is the middle. C is the middle angle. Okay? So which corners have the larger angles? We're going to say angle B is the largest. And angle C is the second largest. Okay? List the angles of A, B, and C in order from smallest to largest. So I'm going to say the measure of angle A is lesser than the measure of angle B is lesser than the measure, oh, I'm sorry. Yep, A is the smallest angle, C is the middle angle. Sorry, I knew I messed something up. And then the measure of angle B is the largest angle. And it asked me to list them from smallest to largest. Be careful if it asks you to go from largest to smallest, you go in the reverse order. Okay? Let's do sides. Why not? Let's just do sides, smallest to largest. Just for the heck of it. Well, it's going to be side BC, which is lesser than side AB, which is lesser than side AC. Yep, AC. All right. The next one, which choice is this? Shows the sides of triangle TUV in order from shortest to longest. Well, I just need a little bit more information. Here we're going to do 180 and we'll take away 58 and take away 62. So that's taking away 120, so I get 60. And that's how I find that angle up there. So the sides are going to be, so my angle, its angle U is lesser than angle is lesser than angle T, which is lesser. I have to put these lines under it because it's kind of hard to even see because I'm using angle notation and lesser signs as well, is lesser than angle V. Okay, and what that means is if U is the smallest angle, its side is TV. So TV is lesser, because you got to go opposite, than UV is lesser than TU. All right, so which answer is that? TV? Well, it can't be this one or that one. TV, then UV. Oh, so it looks like it's going to be A. TV, UV, and UT. Let's move it up a little bit. There we go. UV and TU. I meant TU. Yeah, TV, UV, and UT. Awesome. Nice work. So now we're going to list the sides in order from shortest to longest. Explain our reasoning. So we're going to do 180. We're going to do 180, take away 40, take away 60, and we get 80 degrees because we're taking away 100. This one is 80. And now I'm going to list them. It's going to be YZ is lesser than XY is lesser than XZ. And it says explain your reasoning. The sides, the shorter sides, the shortest sides are opposite the smallest angles. And vice versa. So the larger the sides, the larger the angles opposite. Okay. The next one, using the triangle inequality theorem. Can a triangle have the sides with a given lengths? Explain. Do all of your tests. So do 3 plus 7 is greater than 8. Then do, and then check it. So 3 plus 7 is greater than 8. Does that work? What about 7 plus 8 is greater than 3? And then what about 8 plus 3 is greater than 7? So what I do is I just alternate all three numbers. I move them all to the left. So I normally put them in order. 10 is greater than 8. 15 is greater than 3, and 8, 9, 10, 11 is greater than 7. So that works. Okay. What about 3 plus 6 greater than 10? Then 6 plus 10 is greater than 3, and 10 plus 3 is greater than 6. Well, it looks like 13 is greater than 6, 16 is greater than 3, but 9 is not greater than 10, so this is a no. So the first one's a yes, the second one is a no. It cannot be a triangle. All right, let's do another one. We have 2 plus 7 is greater than 9. We have 7 plus 9 is greater than 2. And then 9 plus 2 is greater than 7. What do we think? You know what? 11 is greater than 7. 16 is greater than 2. 9 is not greater than 9. 9 is equal to 9. So it cannot be equal. So the answer here is no. All right, 4, 6, and 9. 4, 6, and 9. 4 plus 6 is greater than 9. 6 plus 9 is greater than 4. 9 plus 4 is greater than 6. So it looks like 13 is greater than 6. 17 is greater than 4. And 10 is greater than 9. So this can be a triangle. Be careful with this one. Why did I say be careful with this one? Because I don't want you to just get in the habit of just doing this out without thinking. I don't want you to do 2 plus 3 is greater than 12. 3 plus 12 is greater than 2. And and then 12 plus 3. No, 2 plus 3 is greater than 12. 3 plus 12 is greater than 2. And 12 plus 2 is greater than 3. So you would normally say, okay, yep, 5 is not less than 12, but 15 is greater than 2, and 14 is greater than 3. But hold on, zoom in. 12 feet is not in yards. So let's put this in yards. There are 3 feet in a yard. So divide this by 3 and you get 4 yards. Or I could have multiplied these by 3 and put them in terms of feet. So either way, it doesn't matter. But this 12 is no longer a 12. So we got to fix it. 12, that goes away. We don't know what we're dealing with. So we have 2 plus 3 is greater than 4. 3 plus 4 is greater than 2. And 4 plus 2 is greater than 3. Well, 5 is greater than 4. 7 is greater than 2. And 6 is greater than 3. And then you could say, Mr. A, what if I wanted to instead, what if I wanted to instead not use 2, 3, and 12, but instead use, well, I don't have to go that far. What if instead I want to multiply everything by 3 and get 6 feet, 9 feet, and 12 feet, and my answer is going to be, you'll get the same result. Not the same numbers, but you'll definitely always get the same result as long as you're magnifying all of these the same way. So 6 plus 9 is greater than 12. 9 plus 12, 9 plus 12 is greater than 6. And 12 plus 6 is greater than 9. So let's take a look. 18 is greater than 9. 21 is greater than 6. And 15 is greater than 12. So it will definitely work out. Okay. Alrighty. So now we will go to the next one. We have finding possible side lengths. So in this case, you're finding a third side length. All right. Describe the length possible for the third side of the given triangle. So what we have to do for this one is we have to do 10 plus 8. So we're always going to take the larger and add the smaller to it. Is going to be, so 10 plus 8 is 18. And then we're going to take it away because we always want a positive value. So we're going to start with the greater of the two. So 10 minus 8 is 2. So 2 has to be, so the side has to be somewhere between 2 and 18 inches. It can't be 2 inches and it can't be 18, but it can be lesser. It can be greater than 2 inches and lesser than 18 inches. And that's all we do for this one. So we're going to do 12 minus 3, and we'll do 12 plus 3 and 12 minus 3. So we get 15, and we get 9. So there's 9 inches is less than X inches is less than 15 inches. And think about it like this. If you have something and something else, what I can do is I can move this to be all the way out here, but that would make a line. So it's going to be a little bit shorter than that. And that will let you connect your third side of your triangle. In the same respect, you can't move this too much closer than that. So this is when you find the difference of your two sides. This is when you find the sum of your two sides. And those things, those sum and differences, so that's your difference, that's your sum. If it gets to be exactly equal to it, it becomes a line. And if it becomes exactly equal to it this way, it also becomes a line. And so we're looking for a triangle, so it has to be a little bit greater than that and a little bit shorter than this. And that's what we're doing with these side lengths. So we have 12 and 15. So for 12 and 15, we'll do 12 plus 15. So you know what I want to do is I want to make sure I always put the 15 first. 15 plus 12 and 15 minus 12, because I always want my side length to be positive, so greater than 0, right? So 3, I don't want negative 3, I want 3. So it's going to be 3 yards is less than X yards is less than 27 yards. So it needs to be somewhere between 3 and 27 yards. All right, and this last one, we just have to be careful. I put a little note here. You're going to want to convert 2 yards to be, you can convert this to feet. Yeah, I'm going to convert this to feet because it's probably easier to work with feet than to divide this by 3. If I divide feet by 3 to get yards, I have 1 1/3. I'd rather not work with a fraction. It's always easier to expand than to constrict or reduce. So times 3, I'm going to get 6 feet. So for this one, I have 6 plus 4, and I have 6 minus 4. So I have 10, and I have 2. So I have 2 feet is less than x feet is less than 10 feet. All right. This is a very long video, but hopefully it was very informative. And now you see how to find possible side lengths, how to determine if the lengths of a triangle can exist, using the theorem to order sides and angles in order based on what's opposite them, and then applying a theorem to another theorem in terms of what's greater or lesser. Okay, so now we'll do this in class. We'll start with the notes 5.5 and do some practice. But in the meantime, you can work on IXL, or you can do this if you want to get ahead and have it done for class. All right, good luck.